so as you can see on the board, we have 4 debate questions that we're going to go off of. We're going to take roughly 7-ish minutes per question. It would be great if you guys could each try and contribute something per question, or at least 3 questions. So we're going to give a little background before we start debating, just in case maybe you don't know what Zika virus is, or liver cancer, or liver disease, anything like that. So the first question is it acceptable to edit the genome of human embryos to treat genetic diseases? As of right now, genome editing of embryos is not approved for clinical use in the United States. Still, there are many advocates for the genome editing of embryos that are pushing for its use today and in the future. The list of genetic diseases goes on, and the possibility of CRISPR-Cas9 eliminating them is exciting, yet raises many ethical questions. A genetic disorder could be the result of a mutation in a single gene, or it could be caused by the addition or subtraction of an entire chromosome. All right, who would like to start us off? And then we'll just go.
I would say it is not ethically acceptable to edit the genome of human embryos to treat genetic disease until it is widely available to anyone who could suffer from those diseases. If it is only available to the wealthiest of the wealthy in the top 1% of even the most wealthy countries, then I don't think it should be available for public use unless it's regulated by the government and given to anyone who may or already has developed these genetic diseases.
Yes, you can go ahead.
I'm going to agree/disagree. I agree that it shouldn't be used at this point, but because we need further research more on it. But I need to disagree with your point about it being not available to the wealthy. That's not going to be, that's unavoidable. The technology still needs to be more refined and made more, be able to be done at a cheaper price, which means it needs more research into it for it to be made at a cheaper price. So it's going to be expensive at first, no matter what we do, until we get further research at it. And for it to be more available to the people, we just need more time. Which is why I say we should use it in the future. We just need more time for further research on it and seeing we understand what some of the possible side effects could be. We just need further understand it and do it. But I do agree I do say that this should be used in the future. This could cure diseases such as cancer, because one, ethically, we've already done this in the past with antibiotics. We've already treated new diseases or super diseases with that. This is just the same thing, just on another level, and this is the next step in fighting disease and disorders. So I do believe this should be used in the future, but not at this point because we need further time and research.
It's not like expensive, like it's a really cheap alternative to a lot of the other expensive treatments for diseases, genetic diseases such as cancer. So I think it's a really good alternative.
I'd like to protest. No, it's absolutely not cheap. It's actually very expensive. It's close to with embryonic donation and a bunch of other things. It's close to $100,000 or more, just for one, right? Is that right?
Yeah.
According to some articles that I read, it's close to $100,000.
It is still expensive.
Yeah, very expensive.
Well, the CRISPR-Cas9, yeah, the actual method is cheap, but just the resources to have the method are expensive. So what we need to do is make it more readily available.
I have a question for that. Say, for example, if you want to correct a gene, and the first thing is that you would screen the gene, right?
Yeah.
You will screen the sequence.
Yeah.
That portion is expensive.
Right.
And getting the DNA from those patients might be, again,
Right.
a hard task. Getting the sign-in sheets and all that stuff,
Right.
getting the permission.
Yeah.
So some of those logistics have to be brought in the ethical issues too.
Right.
Well, I'm going to dispute your high price. I just did a quick search and I found that average cost of treatment run in the $150,000 range for treating cancer. So yes, it's expensive for CRISPR, but it's expensive for a lot of other diseases. One also found heart attacks may cost around $39,000 to treat. So it's expensive for a lot of other diseases to treat, and so that's just normal. And it's just going to take, like I said earlier, time to lower the cost.
I might be wrong, but I feel like your insurance would cover some of that, right? If you were to go through chemotherapy to treat your cancer, I feel like to an extent they would cover some of the amount that you would spend, but I feel like if you were to try and get your insurance to pay for something like CRISPR-Cas9, they'd be like, no, that's way too experimental. And even if we have more research on it and there's more time put into it so it's more safe, I still feel like most insurance companies would back away from that and be like, no, we're not going to pay for that.
Additionally, I feel like the reason, like you said, we still need more time. I wholeheartedly agree with that. If we ever get to the point where it's easy enough for you to go to a doctor's office and have certain, and effective enough, not just available enough, but it still needs to be able to do, not have as many of the side effects, like, because you can't, there isn't like 100% target rate, like there are often genes that aren't supposed to be affected that are affected, and if we refine it in the future, then I think it could become readily available. And our article is Genetics push for a 5-year global ban on gene editing babies. The video that we watched, which is clearly pro CRISPR, one of the people who produced that video, one of the main researchers, Feng Zhang of the Broad Institute of MIT, is also one of the people who is pushing for it to have at least another 5-year ban, because he himself, one of the main researchers in CRISPR, does not think it is ready for public use, even within the next 5 years, at least.
Well,
I think should we move on to the next question? Alright, sorry, we're moving on to the next question. You can use your points in it though if you would like. So the next question is the use of genome editing for non-medical enhancement acceptable or not? I'm going to give a little blurb about it, then you guys can start. So, it is important to keep in mind that our traits involve a large array of genes and are not only affected by our DNA, but also our environmental and social conditions. For example, height is affected by many different genes located in different spots in the genome, and our knowledge could be obtained as we grow up. It is important to remember that scientists have successfully modified the traits of animals, even our closest relatives, being primates, that involve editing multiple genes throughout the genome.
I don't think it's acceptable at all to make a medical enhancement for someone. First of all, it's not even safe enough to do that yet, because if you were to edit something with this CRISPR-Cas9, then there's a potential chance that it would mess something else up on the genome, and that would create a sort of effect that it's not concerned about, and that would just keep going and keeping mutations. But also, it's not really, like if you're rich, which is basically who would have the most access to this, then you can't necessarily modify your baby so they can be better than the rest of the world, and it would give a step up to the people who are more rich, and I think they already do have a step up, and that would just keep it going.
I agree with you wholeheartedly. It shouldn't be used for non-medical enhancement, but it's non-medical, not medical. Because in the non-medical, it's just going to cause further problems with designer babies and stuff like that, and how social orders work. It's just going to mess all that up, and it's going to create huge problems with that. And part of being human is being different, and if we create this one stereotypical, this is what you want to be, it's just going to be bad and problems with that. So I think in non-medical enhancements, I don't think it should be used, but I've already given my argument on that medical.
I'd like to elaborate on that, but okay, so our evolution will be like we won't be able to evolve like we used to, like we have advanced our population now, because without like diseases and other challenges facing the human race, we won't be able to evolve past those issues, because somebody or CRISPR-Cas9 will be able to fix it, and then we won't be able to, overcome it ourselves. I have a quote. So John Harris, professor at University of Manchester in the UK and author of How to Be Good, claims that the diseases are natural and humans by the millions fall ill and die prematurely, all perfectly natural. If we protected natural creatures and natural phenomena simply because they are natural, we would not be able to use antibiotics to kill bacteria or otherwise practice medicine. So basically, even without disease, we will all pass eventually. It is the process of life, so there is no... Oh. Oh. Hold on. actually a quote for you guys.
Yeah, I was gonna-
So I just read a quote that's for you guys.
I mean,
That's just, yeah, I was gonna point out.
I can add against to it. Yes, Matt?
So I have a point kind of related to Christina's and Zach about like the wealthy people having the like access to this new technique. While I do agree with that partially, in China, how they are experimenting with it is the trials are, they're basically taking people with lung cancer and they're having the sickest of the sick tested out and they're volunteering to use the system. And basically it's starting off, it's just one patient and then they're expanding it to 30, so they're keeping it small. Like you said about not expanding on this too quickly, they're keeping it small and they're testing it on a small group of patients before they expand what the system will be able to do.
Also, with the moral concerns of this is thinking about if you're modifying an embryo, they obviously don't have a say in whether they want to be enhanced or not. But if you're talking about an adult who wants to use this method to hopefully, possibly cure their cancer, then by all means they should be able to do that because it's their own decision and they want to use the method.
Another point I want to bring up is that it didn't say that it was enhancement for humans. It could be for livestock or something, such as Paige brought it up in the discussion how they have been studying how to change because cows in Africa are more used to surviving the heat, but they don't produce as much milk as those in America, and to help deal with the world hunger situation, they could genetically modify those cows to survive the heat, but also produce more milk for the people there.
Yeah,
So I'm just talking like broadly because we're all talking about like genetic and like all the ethical and all of that. But if we look at it in the long run, more people are going to survive using this method. Let's say we introduce this method, let's say in like 7 to 8 years, and now people are surviving through like natural causes, maybe even from like cancer. People died, like millions of people die from diseases and stuff. But if we don't have those diseases anymore, there's going to be a chance of overpopulation, maybe even a drop of maybe even a higher risk of world hunger. That means we're going to have to use it even more for food, which means that it could have a higher cause of mutations, which could even cause more diseases. So this could be a chain effect for using it even more in the future, rather than decreasing the chances of having a disease.
Yeah, I think that as much as cancer is awful and all these diseases are awful, I think that sometimes as awful as this is, how we need them because, I mean, natural selection is a thing, and there's overpopulation in India already. And not that they would, I don't think they would be the biggest users of this, but if we start creating overpopulation in already developed countries like the United States, then it would just make the whole population, or the overpopulation thing way worse, and it would cause more problems than cancer.
Okay, so by 2050, the population in Africa is expected to double and reach 2.5 billion. That's a lot of people. So CRISPR can actually be used to genetically modify plants and crops, which is something they're looking at because a lot of people in Africa live off of basically farming. So if they can genetically modify the crops to grow better and produce more, then that could actually help with overpopulation because even without the diseases, it's probably going to happen anyways.
I just want to bring it back to the actual question about the non-medical enhancements. I think we can all agree that if you want your baby to have blue eyes and both the parents have brown eyes, it's not ethical to genetically modify the embryo to give that child blue eyes. I think we can all agree on that. But because that'll create this population that has a higher sense of self-worth and creates this almost like a caste system of genetically modified babies and then natural babies. I don't get that argument at all.
No, yeah, I understand that, and so does like the U.S. government. Like they specifically said that they are like moving forward. They want to have this method to help cure and help with diseases, but they are against allowing people to make pure babies. So there's going to be like laws and regulations on this method. So just,
Yeah, I feel like if you have some sort of gene editing tool, it's kind of inevitable that some certain rich people are going to be able to use it to create designer babies, because it's almost kind of like the college thing where rich people like are bribing colleges to get their kids into it. I always feel like the same thing could sort of happen with CRISPR, where they'll find a way to bribe someone or pay someone off to be able to allow their genes to have, like, say, blue eyes or more desirable traits. And I think it's just kind of almost inevitable that that might happen.
Well, like, it's already been discovered though. Like, it's gonna happen either way. Like, either way, like they go through with it or not, or like they start using it to like help people who have diseases or something like, or genetic diseases. It's gonna happen either way. That people, like rich people, are gonna like do that. It probably is inevitable, but I don't think that's why. I don't think that's a reason why we should stop using it to actually help people.
Even if even if it happens either way, it can still slow down the process.
Well, it does. Well, I just have to disagree with that completely. If it's going to happen, like we said, either way, no matter what we do, it's going to happen. And since the technology is already here, they can just get it when it's completed, which doesn't solve the problem that it's going to happen. So I think if we don't put time and money into researching this and understanding this, when rich people do want to create their designer babies, there's just going to be more side effects, more problems, more unintended consequences that are there if we don't put time and money and research into this. Because people aren't just going to forget this. If we say, hey, this is not morally right, we should stop going into this, we shouldn't delve into this technology anymore, it's not going to stop people. There's still going to be people who do this without telling anyone, without keeping this secret. It's still going to be there. So what I think we should do is we should keep this going, we should keep this known, because it's going to, so we can have this public, so we're able to improve the system so it doesn't have as many unintended consequences. Because this is just domestication, but faster.
I don't think anyone wants to anyone on this side is advocating for the entire stop of research for this. Like,
it's just the regulation, I think, which is the debate, how much should it be regulated. And I think we all agree that non-medical use should be stopped, but it's just a debate of how much medical use, which I think it should be used in most.
Okay.
Most
so
cases.
We're gonna go on to the next question. So it is, should genetically modified mosquitoes be released into the environment to combat the Zika virus? So I'm gonna give a little background on that. The Zika virus is spread through the bite of an infected Aedes mosquito. These mosquito bite during the day and the night. When pregnant women are bitten, the infection is transmitted to the fetus. There is no vaccine for the Zika virus. In order to combat this, the FDA has approved the release of genetically modified mosquitoes into the environment. The mosquitoes are altered so that their offspring will die before they are able to reproduce. The goal is to reproduce the population of Aedes mosquitoes so that they no longer transmit the Zika virus as well as some other diseases. And the public, however, has expressed concern that possible unintended effects of the ecosystem will be created, and a petition has started to reduce their release. Great. Someone on our side can start this time.
1 million people like die annually. I saw a statistic that like 1 million people die annually from like vector-borne diseases like Zika, and I think that it's really important that we do use this process because you can save so many people from death, and it all costs a lot of money too. Like in general, all these diseases cost around like 3.5 billion a year, and so I feel like that's also saving a lot of money and like helping a lot of people. So I think it's really important that we use this technique.
Also, a quick thing to add to that, I know especially in Florida, they were doing, like chemical companies, they were spraying like mass pesticides in certain areas to try to kill the mosquitoes. So in doing that, it also creates more problems because kind of like, it'll like get all over the bushes, and that can also lead to unintentional consequences. Whereas this system will just, the genetically modified mosquitoes will just target the ones with the Zika, where the spray could also be harming other types of insects, which could be harmful.
I actually have a question. Is there any possibility for unintended over or underpopulation of the mosquitoes, like the mosquitoes? Will they pass on the gene for like a resistance to the Zika virus, or will it just kill all the mosquitoes?
So they're hoping that the ones that they modify either
reproduce with the natural mosquitoes, and that these offspring, they're kind of reproduce so that they die. But as we learned previously, there are issues with the CRISPR-Cas9 method. So there are unintentional cuts which create different mutations which could have negative effects on the mosquitoes and cause different issues.
So if the genetic editing caused just an elimination of certain viruses like Zika virus, virus, or malaria, I'd be all for it. But until we understand what the long-term effects of it could be, such as an over or underpopulation, like say there's an unintentional mutation that causes them to just instantly die, the mosquitoes go extinct, or the population gets diminished greatly.
I just want to say one thing. Let's say that the pesticides are killing these mosquitoes, right? And let's say they were to go extinct. I've heard from multiple people that our food chain would be fine. Even the animals that do eat mosquitoes would be okay if mosquitoes didn't exist. So if these pesticides that you're talking about were to kill all the mosquitoes, then the food chain would likely be fine, and we would, like I just looked it up, it says the food chain would be okay. And yeah, I mean, I know that the pesticides could have an effect on other insects, but I feel like if it's targeting simply just mosquitoes and it's only targeting a few of the other insects, then it might not have a large effect on their population versus the effect that it's trying to have on a large population of mosquitoes.
I think that's, well, I don't think that's how pesticides work. They don't really just target just one type or another. It would affect all of them. And killing off a species, that's another ethical debate. We just shouldn't do that because it will mess up ecosystems. Yes, maybe it won't affect food chains too much, but it's still an entire species gone off the face of the earth that we caused. And it's another one to add to the long list, which I don't think we should continue doing. And I agree with Zach's point completely about we need to see what actually has changed about the mosquitoes, and if it's good and it doesn't completely make them go extinct over population, I think we should continue with that. And I'm just going to, this wasn't really brought up, it's more towards Daniel's debate earlier about how it's just going to eliminate natural selection point. Natural selection does pretty much the same thing. It's just a random human mutation that makes them resistant to the Zika virus. All we're doing is we're speeding up the process. We're taking that mutation, instead of waiting for millions of people to die for a random mutation to happen, for that to randomly happen with luck, we're just introducing it to the human population there, so it doesn't have, so people don't have to suffer a painful death from the Zika virus.
Not necessarily, because CRISPR-Cas9 also have negative
Which
effects.
is why we need to
Well, yeah,
understand. Which is why we need to understand how specifically the Zika virus affects our system. What specifically is it? What part is our signaling pathway? Whatever it's doing. Then we just target those specific areas with the BF9, saying how could we fix this problem? What do we need to edit in the proteins that will make it so it isn't affected by the Zika virus? We edit that specific part. Does it work? Does it not? If it doesn't, we can continue research. If it does work, and there's no unintentional consequences, we can then introduce it to the population there, so they don't to solve the problem.
So you said that the FDA approved this, but when did they approve it for? Like how long from now?
They approved it for at that moment that they approved it. So they approved it knowing that the technology was not fully developed, and that's why the public had such a major concern with it.
My issue with this is how are you able to test random mutation? Because if you released it into the actual environment but not knowing its certain effects because it was already approved, a mutation could occur where the disease could be even worse than Zika, and we have no way of knowing that. So it's it concerns me that we are just saying all right, let's go through with this and let's try it.
Well, the trials will probably be, however we decide in the future to determine, to figure out how
but it's happening
the Capstone works. We then take that environment and see, and I'm just going to use mice for this instance. Let's just say they're infected with disease X, and we take this disease, we figure out how it works, we introduce the Capstone system, we fix the problem in the way we believe it will be fixed. If the system healthy, there's no problem with it, we can continue the mice generation we can take that mice generation, have them reproduce and see in the next couple of generations, is there any huge mutational problems? If there isn't, we can then take the system and see and try and implement it into the human population and see if that was like that, or a system similar to it. And we can do something similar with that if there's any huge genetic problems. We just don't use it as a large scale right away. We do a small scale test to see if there is a problem. If there is, we try and figure out what it is.
But it's not that simple. It's just one single mistake in the CRISPR-Cas9 can cause a large scale effect. Like you mentioned with the mice, how if you breed these mice for generations and generations and there doesn't appear to be any problems, and then we right away approve it for human use, then there's a very great possibility of, like the CRISPR-Cas9 isn't exactly, it's not 100% precise. It's not like you can perfectly target this one gene and not have any any misfiring. There could be misfires like from person to person because everyone's genome is a little bit different. CRISPR-Cas9, one mess up and it could kill the person. It could kill the person. It could kill them before they're even born. There's a lot of issues with its accuracy. It's not 100%.
Okay, so we're gonna go on to the last question, and it's: should adults seek genome editing as a treatment for their liver disease? And so this question was inspired by the study scientists used CRISPR-Cas9 to cure type 1 tyrosinemia. In mice, type 1 is a genetic disorder characterized by elevated blood levels in the amino acid tyrosine, a building block of most proteins. Unlike our scenario, however, to our knowledge, all the mice in the real-world study survived the CRISPR procedure.
I have a point for this one. So for this question, we are focusing on adults, and therefore I believe it is ethical because these people can make their own moral decision using their own values to choose if they want to be a part of this testing and treatment for their own personal liver disease that they have as an adult, where they can make their own decisions. And also the point was brought up that all of the mice in this study did survive, and it worked on them. Yes, humans are not mice, but it is still working so far, and if they want to be a part of that treatment, they should have the right to choose that.
I'm just going to have to ask, does Capstone system work differently in adults versus embryos? Because there could be a very big problem. Because if the change in DNA happens in, let's say, a part of the adult's cells, not completely all of them, that could be a huge problem with how cells interact with each other if there's a difference like that. So in adults, I'd have to say we'd have to have a lot more time and understanding into how the system works in adults versus children.
That's a good point. Definitely being able to see the differences if there is one between embryos and adults. But if you go back to remembering our presentation in that video specifically, that guide RNA will connect to the right spot in the DNA where it matches up with those base pairs.
So it's actually really unethical because if they are deciding for themselves that I want to treat my liver cancer as an adult, it's going to in turn affect their offspring. So basically they're not just making a decision for themselves, they're also making a decision for the future generation. And they don't have their consent to do that, and
don't think that it would actually affect your offspring because it's not going to be a genetic thing that you're changing. Liver disease is something that you get from something that happens in your life. So
So not in liver disease, but for example, in any other kind of thing that you want to fix in yourself, it's going to affect the next generation regardless.
Well, I think this is my assumption of how the system would work, is that they take a reading of the current DNA of a healthy cell in the human liver cell. Then you can take the then you take the mutated DNA in the cancer cell, and then you're able, which is different in all of the cancer cells like we just said, so it's going to be very difficult. But then you can introduce a CRISPR-9 system to replace the new mutated parts with the current healthy DNA in the liver cells. So it's not a different, so it's the same DNA that the person had the entire life, it's just replacing the mutated portions, which would be entirely different because, like you just said, the cancer mutations are different in all cells instead of cancer.
Is the liver disease that we're talking about, is it genetic, hereditary disease, or is it like, for instance, like alcohol, like the liver disease developed by like alcohol use?
So that's actually a really good question because it depends on how you look at it. So there are some liver diseases that can be genetic while some are not. So the genetic ones would affect your offspring, and like say ones from drinking or like other things would not affect.
The only way that it could affect your offspring is if the germline cells, like your sex cells, like the sperm or the eggs, are genetically modified. So it wouldn't be passed on to your
And what if
offspring.
it's a recessive mutation? You know,
Right,
it can
unless-
pass through.
Right. So you do have to look into that. It's a good point that you brought up, but for this specific liver disease, it wouldn't, unless you were specifically modifying those germline cells.
And I definitely, if it's a non-hereditary liver disease, do not think it's ethical for them to treat themselves with that. If you make your decisions in life just because you have more money than the average person, I don't think you should be able to bypass the decisions that you made in your life because you made certain decisions that made you develop this certain liver disease. I don't think just because you make more money than the average person, you should just be able to, you know, have a greater chance of living compared to someone else because of something that you prove to yourself. It's just,
If we give like an example, let's say it was from too much alcohol, like most adults probably have children, they probably see that they drink a lot. But then if they have like this genome editing so that they can fix their liver disease, then there's a huge chance that they'll drink even more, thinking like, oh, I'll be fine, I can just genetically edit myself and just be fine, right? And then your children will be like, oh, that I can drink too, that means I can do it too, because we have the money, right? That will raise like so many more chances of like accidental car crashes, which would also be like a huge like depopulation, like drop in population. So I feel like this is both unethically and even like for people's safety's sake, it's just not right to genetically modify something that you think will be, yeah, this will be fine. I can just do it again if it doesn't work.
But what if someone's in the hospital due to their liver not working anymore, and they're on death row because of it? Are you saying that they?
Specific situation.
Yeah, but then shouldn't they not be allowed because that? I think it should be allowed for those people that need it for survival. If they're dying and if it's due to bad life choices, yeah, it's their fault, but they're gonna remember that experience.
Okay,
Sorry,
so
unfortunately we have to end the debate.
I don't think it's.